Thank you for joining. Let's give everyone a minute or so to join before we get started here. Thank you for those that joined on time. And so today we will be covering the MQTT basics for our EMQ University Live. What is MQTT? Is a question that I receive a lot, whether it's interacting with our new clients, going to conferences or events, and even during our webinar series. And so today we'll be going over some MQTT basics. But before we start, let's start a level above that with IoT. IoT is the Internet of Things. And so instead of computers or a tablet or a phone joining the internet, IoT, the Internet of Things, is just that: things, sensors. These things may not have computers inside of them. They may not have even a default network connection. So this could be legacy equipment or sensors that originally was not designed to communicate over the internet. But these sensors, these things, have valuable data that if we were to have access to the data of all those sensors, it allows us as an enterprise to make data-driven decisions. So MQTT has really become the default, the premier protocol for IoT, for the Internet of Things. And also you may have heard the term IIoT, which is Industrial Internet of Things, which is the same concept, but in an industrial environment. And so what we hope to accomplish today is we'll get you some of the basics of MQTT so you can understand the protocol itself enough to design, maybe troubleshoot your own IoT workflow. So let's get started here. So I am Ernest Russell, a technical content manager for EMQ, and also the host of many of our webinars. It's always a pleasure to speak with you. Some housekeeping things: we do have Q&A at the end of this. The presentation will be roughly 30 minutes, and I've set aside sometimes for Q&A. Chat is disabled, so please put your Q&A into the Q&A panel. And if I do not get a chance to answer your question directly today, I'll make sure that I follow up with you on email. So MQTT, let's start with the design, why it was designed. MQTT was originally created by Andy Stanford Clark and Arlen Nipper. At the time, Stanford Clark was at IBM, Nipper was at Arcom Systems. And this was in the early 90s. And the initial concept for this, it wasn't called MQTT then. It was MQ space TT, and that has changed now. We just use MQTT. It technically doesn't stand for anything anymore, but it is a well-defined standard, and we'll get to that. So MQTT was originally designed for SCADA systems, and that's because ConocoPhillips, the crude oil pipeline, needed to be monitored And a lot of those devices that's how they communicated. So SCADA, PLCs, and again, that data, which is very valuable, was not available remotely and unable to consolidate that data in a good way. So MQTT was the project that made that achievable. And so there were a couple things that are required of MQTT based communication. One is that it's lightweight and bandwidth saving. So using as little data and as little resources and as little bandwidth as possible. And part of the reason for that is, as you can imagine, in 1999 or early 2000, there was not great internet and cell coverage. If you had remote sensors or remote system, it was connecting over maybe a satellite system like VSAT, which bandwidth is at a premium. So we want to make sure that we're reserving that and using that bandwidth responsibly. So so from the start, MQTT was designed to be lightweight, both on the CPU and memory and storage side, but also on the bandwidth side. Also, it MQTT systems need to support different quality of service levels or QoS. And that different adjustment in quality of service levels allows you to make decisions and help monitor and route your data responsibly. And so we will go into the different QoS levels within MQTT and how those apply to different workflows. MQTT also needs to be data agnostic. And so what does that mean? That means we don't care what's in the pipe. We don't care what the payload is. That payload can be a picture, it can be a short video snippet, it can be JSON. So it can be that payload doesn't matter. It's we're able to create the session, create the connection, and transfer that data reliably, no matter what type of data that is. And also, so with QoS, that inherently we need some session awareness, which means we need to know if the client is connected or not. And I'll show you some ways that MQTT helps to reveal that. And MQTT is maintained by Oasis. So Oasis, it helps provide a clear path to standardization to make sure that the different industries that are using MQTT within that IoT realm, it gives that standardization so we don't end up with a proprietary systems that aren't interoperable. So a brief history of MQTT, as I mentioned, it was originally conceived at the time with IBM. It was released to everyone or made an open standard in 2010. And at that point, it was at version 3.1. So this is often referred to as MQTT version 3. In 2014, some enhancements were made, and Oasis published a new version, which was 3.1.1. This is often referred to as MQTT4. So if you hear the term MQTT4, it's often interchangeable with MQTT version 3.1.1. In 2019, version 5 was released, which is now the latest version of MQTT. There's a lot of good improvements, that enterprise level, I would say, improvements within version 5. And so in today's discussion, most of what I will talk about applies to version 5. So if you are running a system that's older than 2019 and haven't made any updates, it's very likely that you're running an older version of MQTT that may not have some of the features that we've talked about. So if you are and haven't upgraded since then, reach out to us and see how we can bring you into the new tech. In 2020, EMQ joined Oasis as a technology contributor. So we, at EMQ, we really consider ourselves innovators in this space. Our main focus is our MQTT platform. So we're not distracted by trying to develop other systems or solutions. Our platform is MQTT based, and all of the development, the innovations that we put into MQTT, we work with Oasis to help standardize those, again, to make sure that you don't end up with a proprietary system. A system that's most interoperable is the goal, and enterprise level dependability. So the core components of MQTT, MQTT is what we call a publish subscribe model. And it's fairly simple once we break it down into these four components. The publisher being responsible for publishing messages to a topic or different topics, a subscriber that receives those messages from subscribing to those topics, a broker which sits in the middle between clients and is able to route messages by topic, and the rules engine, which I'll talk about shortly. And the topic is really what categorizes those messages for routing and allows our publishers and subscribers to connect and send or receive the messages needed. So let's take a look at what that architecture looks like. And I'll give you this simpler version first, and then a little bit more complex version as we help working through understanding these IoT systems. So you can see on the left side here different types of sensors. These could be, we work across so many different industries that have this challenge of things that need to connect to the internet. And again, most times, these aren't computers or tablets. These can be light bulbs. These can be sensors within a building. They can be robotics on an assembly line. They can be chargers for connected vehicles, or the connected vehicles themselves and the telemetry that they provide from different data points. And so all of those things in the IoT world become publishers and or subscribers in our system. And we have MQTT, which I'm going over the basics now. There is a different version, what we call MQTT-SN, and that's MQTT for sensor networks. And so we are compatible for that. That's for systems or sensors that may be battery powered and may go to sleep and come back. So we have some efficiencies that help in that type of model. And we are the first MQTT broker to offer MQTT over Quick, which uses the UDP protocol. Typically, most of these systems are built over TCP/IP, but we can operate over different transport protocols as long as they're ordered and lossless. So we talked about the publishers on the left here, which are your sensors. And you can see in the middle here sits the MQTT broker. And you see several here because most of the time, especially at the enterprise level, we want to deploy these brokers in clusters. So to be able to support any number of publishers or subscribers that that you need. And also that allows us some admin things on the back end where, for instance, we can do rolling upgrades without taking the complete system offline. And so the broker sits between the client. So the client does not have to have a direct connection to your backend systems. That broker will handle any transactions and help filter the data that you need to move, let's say, into the cloud or into your backend systems. And so that's what you see here for the rule engine and the action. And I'll go into a little bit more detail on that shortly. But that rule engine typically is SQL based. And so with some very easy commands, simple commands, helps you filter the data that you need to deliver to your backend systems. That backend system can be other MQTT brokers. It can be a system that you use on your back end with AWS or Google or Azure. But that MQTT broker becomes a key part in connecting your edge data, your edge sensors to the cloud and to your back end. So now that we understand what a publisher and a subscriber is, let's look at topics, what an MQTT topic is. So an MQTT topic helps with message routing. In this example, we have two sensors, sensors 1 and 2, that are publishing their local temperature. And we have two subscribers, which we're calling app 1 and app 2. So app 1 is subscribing to sensor 2 and receiving the temperature of sensor 2 temperature. And that's what we call levels in a topic. So topics have different levels. Level 1 would be sensor, which would be the base level. Then level 2 would be the description of 1. And level 3 would be the temperature. So in this topic, we have 3 levels, and any of the clients could subscribe to any or all of these levels. Now, I'll show you how that's achieved. So again, sensors publishing a temperature and apps subscribing to that published data. And we can choose what data that we subscribe to by choosing a topic. So speaking of topics, let's talk about some best practices for creating these topics. One is you want to use meaningful topic names. So what does that mean? That means human readable, right? Meaningful topics. So for example, home, bedroom, temperature, right? Or home, bedroom, sensor one temperature, if we have multiple sensors, right? So that even without subscribing to and reading the payload of that topic, it's human readable and understandable what information I want to receive or send with that topic. And secondly, those you want to organize those hierarchically, which means basically we want to use those slashes to organize the different levels of data within the topic. So it is case sensitive. So for example, home, capital home slash temp is very different from lowercase home slash temp. And so that is a common mistake that we see that causes you not to receive the data as expected. So understand these are case sensitive, and so you want to make sure that you don't have spaces, you don't have characters that are not readable, and typically you want to stay away from slashes unless you're using that to separate a level, separate and create a different level within your topic. So in this example, slash chat, all right, we don't want to use that as a topic name and end up with two slashes where it creates an empty level. And third, we want to limit wildcards because they can match some unintended topics, meaning you may end up receiving more data than required, more data than necessary, and also you can use more resources in that way. And the point of this protocol is efficiency, right? It's about using those resources and using your bandwidth efficiently. So I'll go a little bit deeper into topics and wildcards. So there's two symbols that we use for wildcards. One is the plus sign, which is used to as a card for single level topics. And so single level topics are represent one of the levels, right? So one slash, in this case, sensor slash two slash temperature. If we were to add sensor slash plus slash temperature, that will allow that subscription to that topic for any number after sensor, and it would return the temperature for sensor 2, 3, 4, so on. So again, we want to be responsible with how we use single level, and also the pound sign or hash sign, which is used to map entire topic trees. And so that's the difference. Is the plus is single level, the pound is multi-level. So um, let's see that in a little bit more detail, and what's valid on single level and multi-level wildcards. So in the example here, just plus is a valid is a valid wildcard, and that would, in this case, that would subscribe to sensor. It would subscribe to everything within that level one. Sensor slash plus is valid, right? And that would subscribe to everything within level 2 as a wild card. So sensor slash plus slash temperature is valid, and that would return every sensor's temperature essentially. Sensor plus is not valid. And the reason why is it doesn't occupy an entire level. So sensor plus would not be a valid wildcard without the slash, which would create another level. In the case of multi-level wildcards, a sensor slash pound is valid. And again, that would return every level after sensor. So a lot of if you have a lot of sensors, if you have complex topics, you can see how this may return more data than needed. Sensor slash bedroom pound is invalid. And again, you want to make sure that that wild card is the last level. So in the same case here, where you have sensor pound slash temperature, that's invalid because once you use that pound, it's assumed that you want to subscribe to everything after that level. So temperature becomes redundant here and invalid. So now that we have all those core components in place, another requirement of MQTT is being able to provide a level of quality of service. And there's 3 levels of quality service in MQTT, QoS 0 being at most once, QoS 1 being at least once, and QoS 2 being exactly once. So QoS 0, we often refer to that as fire and forget. And so when you have a, a good number of sensors that are providing frequent data, it may not be necessary that you make sure that each message is received at least once or exactly once. It may be in, like, let's say in the case of temperature, it may be okay to receive the temperature, and if you miss a message with the next interval, you can get that update. QoS 1, at least once, it ensures that message delivery, and I'll show you how it ensures that. But it can produce some duplicates. And that's where QoS 2 comes in. There are some additional handshakes, as you can see the interactions here, that are able to perform deduplication to make sure that we only receive our message once, exactly once. So in order to achieve these QoS levels, there's one thing that needs to be implemented within MQTT, and that is a session, okay, or a persistent session. In this case, you see the session here represented in green, and that session can span multiple connections. So in this session, we have 2 different connections and that are established between the client and server. And the client can use this session and reuse this session if it's persistent. So if there is a disconnect from the client or from the server, it can rejoin that session. And so when we talk about sensors, when we talk about sensors that may go to sleep in certain intervals, we may not want to go through with the reconnect dance each time, right? We may want to wake up and the sensor reuse that same connection. And so that's where the value of persistent session comes in. And also the persistent session helps facilitate the quality of service level in that there are certain parameters that the client and the server need to be able to track in order to be able to facilitate those quality of service levels. So for example, if there is a disconnection on the client or the server side, the client needs to know what messages are waiting to send, what messages have been sent but not confirmed yet. And the server needs to know what messages are waiting to send, what messages have not been confirmed, and also what subscriptions are out there. And so that session again becomes very important in making sure that we could achieve those quality of service levels necessary. And so in this case, you can see the session reconnecting clean with a clean start equals 0. And which means we want to, if we have a session that exists, we want to reestablish and reuse that session. And how it makes that association is client ID, which is sometimes set by the client itself when it joins. If not, the server can issue a unique client ID. And that's how the session is tracked. A clean start of 1 equals means that we want to start a new session each time. So depending on your workflow needs, you may want to, again, just hop back onto that same session and reuse the same connection. Or you may be have the need to require a new session on each connection. And so you have that flexibility. Um, and so we've covered a lot here. We're almost there. So again, any questions you have, please put those into Q&A. I do have a couple questions I see here I'll get to shortly. And if I don't get to your question, again, I'll make sure to get with you on email. So the last concept I want to cover here before we do a recap is last will messages. And because this becomes an important detail in MQTT communication in tracking to make sure that a session exists or that the client is online. And you remember that was one of the initial requirements of the protocol is that we know the status of the client, that we know if the client is online or offline. And so how that's one of the ways that's achieved is last will messages. When the client connects, it creates, in the same way a person would create a will while they're alive, what they want to happen in case of their death. It's the same thing for an MQTT connection. So while that connection is alive, when that connection becomes alive, it specifies what it wants to happen if that connection drops. For example, if the client ID, if a clean start is required, and the will payload, what do I want to say if I'm disconnected? So that could be as simple as, hey, I'm offline. And that is able gives us the ability to react to that, right? It may be as simple as turning the status of a bulb from a green to red when a client goes from online to offline. So those messages are specified when the client becomes online, and with MQTT 5, we have what's called a will delay interval. In the case you see here, we have an interval of 1 minute. And so when the client disconnected, then the broker is no longer receiving communication from that client, has not during that period. And so the message, the will payload, is then published, right? So that that sensor within, even though it's not online anymore, it would be able to publish the message that, hey, I'm offline. So that helps you maintain sessions and helps you keep track of what clients are connected or disconnected. So now that you have an understanding of, of the core components of MQTT, let's look at designing your own IoT workflow. So in some cases, that may be as simple as smart devices in your home. We have a lot of clients that I've met at shows and events that are using MQTT to manage their home automation. So again, those devices on the edge over here, that can be home devices, that can be charging stations for smart vehicles, that can be monitoring and an industrial assembly line. So those devices sit at what we call the edge, right? So those are devices that are on your side, whether in your home, in your business, in your enterprise. And through network connectivity, we bring that into the broker. Our broker is very versatile in how it can be deployed. So, for example, in a home monitoring system, it may be deployed on a device as simple as a Raspberry Pi because it doesn't use a lot of resources. So we can use very lightweight hardware to run the broker. In more complex scenarios where we're talking about enterprise devices and scaling up to millions of devices, we may want to do a Docker or Kubernetes deployment into the cloud. And so that cloud could be private cloud, public cloud, or even a hybrid of both. And we are very versatile in how you want to deploy that. So if you have the IT and the operations staff to implement this in your cloud, we provide all of the tools and support. Or you can choose a fully managed cloud-based system where you just log in and start to connect your sensors and start to create your topics. I'm almost there, Christopher. I do see your question almost done here. One thing I would like to mention before I conclude is so we as that broker that sits in the middle, since we're connected to both the edge and the cloud, we are that pipeline to your backend systems. And so we have data bridges, webhooks, plugins that are able to take that filtered message from your, again, filtered through our rules engine to give the specific data needed for each one of your back-end systems. So sometimes that's databases, sometimes that is feeding into AI systems, artificial intelligence, or machine learning solutions to be able to analyze that data over time and recognize trends. That MQTT broker becomes an essential part of creating your IoT workflow. And so hopefully understanding the basics of MQTT will help you design and troubleshoot your IoT systems. And if you need help, we're here. Our We are very good as a team on creating tutorials, blogs. We have several monthly webinars. We have this one where we talk about different solutions in different industries, and we also have one with our development team, what we call our office hours. And those are more interactive, where we want to hear about the systems you're working on and some of the challenges that you have. And in some of those cases, you are the one that gets to choose those topics. So make sure you subscribe to us on LinkedIn, on social, on Discord, on Slack, so we can talk to you about your workflow. And so I do have, let's get to a few of the questions here. So Chris is asking, what would you recommend for folks who have active projects and need to learn the nuts and bolts of MQTT setup? I have a few corporate projects, and I can only get so much from general YouTube videos and white papers. I have the EMQ broker and have devices talking, but need to dig deeper into how to best handle data gathering. I love that question, Chris. And I'll give you a few starting points. For one, I would identify the requirements of what you want to get out of your publishers or your sensors, and then what systems you want to deliver that data to, right? Is that a database? Is that a mobile app? Right? And so that understanding those pieces first will help you to get into the nuts and bolts of how to directly connect to those systems. Now, most IoT databases out there and cloud databases, we already have plugins to connect to, and that knows how to deliver data to those systems. So you can connect to those with very little or no coding. And once you're able to identify the systems you want to connect with, we have a tutorial, step by step, to have you connect. And again, our team is almost daily produces these tutorials to make sure that that our customers are getting that interaction. And we do support different levels. We have forums out there that you can access for free. But if this is a corporate or enterprise incentive, a lot of times our customers connect with us through Teams or Slack. And so we set up a channel for you and your engineers. And every step of the way, when you have a challenge, when you can't connect, when you're getting data that you're not expecting, you're able to connect with our team directly on that channel, and they'll get right back to you. And so I would say that's definitely, when you're talking about corporate projects and staying on time and fast implementation. I would say it's definitely worth looking at some of our managed implementations, so that, for one, we can make sure that it's set up efficiently and you're getting the most out of your bandwidth, your connection, your hardware, your back end services, and that you're able to implement this on time. So excellent question, Chris. I appreciate that one. I have another one here from Victor. I hear that Facebook uses MQTT for Facebook Messenger to send chats to clients. Is MQTT a good protocol for chat apps? Is there a better protocol for this use case? Victor, I can't speak directly for Facebook. I can say that I have worked on real-time messaging systems that use MQTT, and I'll tell you why. Many of the systems that are out there for chat, just like video delivery, they have some latency built in, and sometimes this latency could be several seconds. And so it becomes odd when when you're chatting and you don't get a response right away. You have that pause in between. So that's the reason why MQTT is such a desired protocol in this case, in that our latency is sub-second. So it's for human interaction, that's considered real time. And so as I send a message, you're seeing it. As you send a reply, I'm seeing it. So yeah, MQTT is used for a lot of messaging systems, and when they are attached to video also, right? So if you have a system where you're showing your video and chat, it's a great complement to those types of systems. I do have a couple more questions to get to. Maybe this is a topic that we'll share again, or revisit during our office hours. So thanks to all that joined. Those that weren't, I will make sure, and these couple questions I will get back to you with on email. And as always, thanks for joining. We'll see you next time.